So among shapes, we have something called a polygon. Now, a polygon does not have any round or arcs or curves. So a circle is not a polygon, neither is an oval or an ellipse. Anything like this, for example, where there's a curved part, that is not a polygon. Yes, it is a shape, but it is not a polygon. So a polygon is going to have these corners, and these corners are called vertices, plural. Singular is called a vertex. And when we connect one vertex to another one with a line segment, that's called a side. So for example, this is a polygon. It has 5 sides. It has 5 vertices. These are the vertices right here. And in this case, this is called a pentagon because there's 5 sides. And in order to name a polygon, we pretty much pick a vertex and then go around. So this is polygon PQRST. Or if we wanted to start at T, for example, we could say this is polygon TPQRS. Or if you want to go backwards, TSRQP, that's also fine as well. But don't complicate it. This example right here is of a polygon that's convex. It hasn't caved in on itself. Here are some shapes, and let's identify these as polygons or not. So this one is a polygon. Right, it's enclosed. Now, to be a polygon, you have to be enclosed all the way. You'll see what this means in a bit. So yes, this is a polygon. Yes, this is a polygon. Yes, this is a polygon. No, that's not a polygon because of this curved part. No, this is not a polygon. Yes, there are line segments and there's vertices, but you see this vertex doesn't meet, actually this point doesn't meet this point. There's a gap. This is not enclosed, so that's not going to be a polygon. And this last one, you may think, oh, well, there's 2 polygons. Well, we're asking for 1 polygon. And on top of that, polygons, their vertices don't end up meeting other vertices. So like this triangle up here has a vertex right here, but this one also has one down here. And the 2 vertices are being shared. So vertices don't get shared among polygons, right? So like, for example, here, 1 vertex, and it's got 2 line segments going to it. 1 vertex has 2 line segments going to it. Pick any random vertex and it has 2 lines going to it. But over here I have 1 vertex and I have 4 lines going into it, and that's why that's a no. So among these 3 polygons, let's kind of see a few things. How many sides does polygon A have? It has 1, 2, 3, 4 sides. So this is a 4-sided polygon. B has 1, 2, 3, 4 sides. That's also 4-sided polygon. And this is 1, 2, 3, 4, 5-sided polygon. These have specific names, which we'll get to later on. Let's talk about concave and convex. So polygon B is convex, and polygon C is also convex. We say that A is concave. And here's why. If you were to draw a line segment, all the way through a line segment, and if it actually goes inside of the shape, then it's concave. So for example, if I do this with C, right, if I made this a line, it never goes on the inside. Or if I made this a line, it never went on the inside of the shape. Or if I drew a line through this one, it doesn't go through the shape. Same thing with this one, same thing with this one. So if we extend every side into a line and it actually runs into the inside, then it's concave. Otherwise, if you want to just recognize that it caved in on itself, then it's concave. For example, here is a convex pentagon, and then here is a concave pentagon. You could almost consider this as a house, right? This is a house with the windows and the roof is up here, and then on here the roof collapsed. In further describing polygons, we've discussed this with triangles. We're going to review it for a moment. A polygon is equiangular if all of the interior angles are congruent. It's equilateral if the sides are congruent. But now, what if it's both? If it's equiangular and equilateral at the same time, we call this polygon a regular polygon. So in the past, when we talked about equilateral triangles, right, being equiangular at the same time, we could have just said it's a regular triangle, Now, regular in this case doesn't really mean it's common. Regular means this is a very, 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 very special triangle or polygon, because not only are all the sides congruent, all the angles are also congruent. You might want to consider a square, for example. We know that a square, all the angles are right angles, and we also know that all the sides are congruent. So a square is a classic example of a regular polygon that's four-sided. So let's look at A, B, and C and identify these as either equilateral, equiangular, or regular. So we look at the sides and notice that they all have one dash. That means that all four of these are congruent. So this is definitely equilateral. When looking at the angles though, this angle is congruent to this one. They're both obtuse and they both pair off because they have only one curve. But then these two acute angles are congruent to each other. All four of these are not congruent to each other. They pair off. So in other words, these two are congruent to each other, but they are not congruent to these two, which are congruent to each other. So that's it for A. We're done. It's not equiangular, it's equilateral, and that's it. For part B, we notice dashes, and they all are single dashes. That means this is equilateral. When we look at the curves, do you notice that all of the angles have the same curve and the same amount of curves, right? There's one arc or one curve for each angle. That means that all of these angles are equiangular. Now, if a polygon is equilateral and equiangular, that makes it regular. So we could call polygon B to be a regular polygon. And in this particular case, there's 1, 2, 3, 4, 5 sides. So this is a classic example of a regular pentagon. Part C, let's see. Let's make sure that each side has the same dash. So they do. This is equilateral. However, when we look at the angles, we're not seeing anything going on here. So this is not equiangular. All we know that is that this is equilateral, and that's it. Also, just for extra practice, notice that A is convex, B is convex, C is concave. If you were to draw a line to this line segment right here, you would notice it actually goes in the inside of the shape. That makes that concave. If we were to pick a vertex, so for example, if we pick vertex Q for this polygon, PQRST, and we were to draw a line segment from this vertex to other vertices, these are called diagonals. Now, we're drawing, for example, from here to here and from here to here. We don't draw from here to here because that's a side. So that's not a diagonal. A diagonal actually goes through the inside of the shape. So, for example, from vertex Q, I can form two diagonals. If we look at problem 2, part A, and play around with that again, let's say I pick vertex A, I can draw one diagonal from A to D. If we look at a stop sign, you'll notice that there's 8 vertices. This is an 8-sided polygon called an octagon. And if we were to pick, for example, this vertex right here, I can draw 1, 2, 3, 4, 5 diagonals from the same vertex. So diagonals are drawn from the same vertex. Don't be doing crazy stuff on me where you're making like stars and stuff with it. When we draw diagonals, it tends to be from the same vertex. So in this case, an octagon has 5 diagonals, which incidentally ends up forming 6 triangles if you look carefully. For your summary, go look on the internet somewhere or a book or whatever, or Wikipedia is great actually for this. Make a table of common names for polygons with 3 sides all the way to 12 sides. So, for example, you're going to want to say, hey, number of sides, and then what is it called? Right? So, if there's 3 sides, it's a triangle. Wow. If it's 4 sides, you get the idea. Go all the way to 12.